Okay, so I wanted to work a few of these word problems for you because I know they've been a little difficult. They're tricky word problems. Trigonometry is a very complex structured unit because of the circles and the repetition, so that if you have, let's say, a 20-degree angle, then that angle could also be represented by a negative angle of 340 degrees, or it could have a cosine that is equal at 20 degrees and at 340 degrees around the circle. So there's a lot of overlap with it, which can get very confusing, so that the answer might be 20, it might be negative 340. So we want to work these in a very methodical way. So here we have T at T models the daily high temperature in Santiago, Chile, T days after the hottest day of the year. Now, the key for all of these is that it gives us the model. So here we have 7.5 cosine 2 pi over 365t plus 21.5. That's a lot. But what is the second time after the hottest day of the year that the daily high temperature is 20 degrees Celsius? So it's telling us this is T days after the hottest day of the year. We just need to figure out when it equals 20 degrees for the second time. So let's solve the equation for a temperature of 20 degrees. Let's set that up. So we know that 20 is the temperature that we are after. So that's going to go here. And then we have our equation, 7.5 cosine of 2 pi over 365 t plus 21.5. Which all that's saying is that you're splitting the period into 365 days, so you should recognize those numbers at least. But this is an isolate, resolve, and solve problem. We need to isolate the cosine and then solve by taking the inverse cosine. So we're going to do that. I'm going to subtract the 21.5, so 20 minus 21.5, and then divide by 7.5 to get negative 0.2 is equal to the cosine of 2 pi over 365t. And then we're going to take the inverse cosine of this to get that. So we get the inverse cosine of negative 0.2 is equal to 2 pi over 365t. And then we're going to take the inverse cosine of that. So we're going to draw our little picture out. Negative 0.2. So we have an angle in the second and third quadrant. So that's going to be the first time the temperature is 20 degrees. That's going to be the second time the temperature is 20 degrees. So let's do our inverse cosine. Where is it? There. Inverse cosine of negative 0.2 in radians gives us 1.77. So this angle right here is 1.77 radians. Okay. But we want this one really. That's the one we're after. So I need to figure out if this is 1.77 all the way there, then I can find this one by doing 360 minus 1.77, or 6.28 minus 1.77. So this one's 4.51. Which again is, this is, let's say that's about 130 degrees all the way around to that angle. So I went, well, if that's 130, then 360 minus 130 would get me to that third quadrant. So again, using that circle, the fact that there are 360 degrees in a circle, there's 180 degrees in half a circle, to kind of find those angle measures. Okay. But all we've done is evaluated this inverse cosine. We still have this 2 pi over 365 to contend with. So my answer is 1.77 or 4.51 is equal to 2 pi over 365 t. And t is what we're after. We want to know what is the second time after the hottest day of the year in days that it hit this. So really we're after the 4.51. The 1.77 would be the first time. According to this model, the 4.51 would be the second time. So really it's just that one. But we have to solve for t, which means getting rid of this. So we're going to do 4.51 times the reciprocal of that, 365 over 2 pi is equal to t. And then it's just a matter of doing that. So 4.51 times 365 divided by 2 pi gives me 261.99. So about 262 days. Let's see how we did. Let's put in 262 days. Let's see if that is correct. Good. That's okay. It's difficult. It's a weird way of thinking about it. Take some practice, but they're going to give you the equation. They're going to give you a value that you're trying to solve for, and then it's just isolate, resolve, and solve, and kind of working your way through. Radians are hard because they're using these decimals. If we were in class, it would have been much more about the unit circle, but I'm working with what I'm given. So, t seconds after, when does one first reach a height of 16 meters? The same idea, you're going to set it equal to 16 and solve. So that one works the same way. I don't think it lets. Anyway, so that's the idea. It's isolate, resolve, and solve, set it up. There are no word problems on the test for this unit. I just want you to interact with them and try to think about the trigonometry in a little bit more complex way. But all you have to be able to do on the test is solve the basic equations and the harder ones that require isolate, resolve, and solve. Make sure you know the unit circle and that you can do the exercises before the word problems. Attempt this one. Do your best. But you are not going to be tested on the word problems. And from here, it is very difficult to keep going with the trigonometry that we would have covered in the classroom, because Khan Academy doesn't have it up here. It's very difficult not to do from distance learning. So we will then be moving into statistics next week. Those are probabilities, ways of counting outcomes, and sample sizes and surveys and all that good stuff. So probability next. We're almost to the end because we had to cut a lot of curriculum. But hopefully everybody's staying safe. If you need any further assistance or you'd like to see something added or you need any help on something, please email me. But otherwise, keep going, guys. One more month.